Trajectory of a projectile motion. In today's session, we are going to derive the equation of trajectory of a projectile. And in later half of this session, we will do couple of related problems. Projectile motion is the motion of an object in a vertical plane with some initial velocity u and under the influence of gravity. So the object is under influence of acceleration which is equal to free fall acceleration g due to gravity. And this object which is projected is known as projectile, and the path followed by this is known as trajectory of the projectile. This trajectory of projectile shows the location of projectile in space, and mathematically it is the relation between x and y coordinates, and this relation is known as equation of projectile trajectory. Now question is how to derive the equation of trajectory. There is a three-step method for it. The step 1, find the x coordinate of particle at any instant of time. So here the x as a function of time t. The next one is find the y coordinate of particle at the same instant of time. That means y as a function of t. In the third step, eliminate this time t from equation 1 and 2 and get an equation which is correlating the x and y coordinates. The y as a function of x. Now let's consider a projectile motion. In this projectile motion, the object is thrown or projected with initial velocity u at angle theta with the horizontal. This two-dimensional projectile motion can be considered as a combination of two independent linear motions in two perpendicular directions, x direction and another is vertical direction which is y-axis direction. The component of u in x direction is ux which is equal to u cos theta, and component of this u in y direction is uy which is equal to u sin theta. Now let's consider a point xy at time t on the projectile path. Now we have to follow the three-step method to find out the equation of trajectory of this projectile. In x direction, motion is with constant speed because there is no acceleration. Acceleration is always vertical and in downward direction. So here the displacement in x direction is x equal to ux multiplied by time. So this is our first equation where x is presented as a function of time. The vertical displacement y can be given by the motion equation for constant acceleration. Y is equal to uy t plus half at square. So here a is equal to minus z. So we can say half z t square. And this is vertical displacement as a function of time. So now as a third step, we have to eliminate time t from these two equations. So from equation 1, we can say t equal to x by ux. Now this value of t we will put in equation number 2. So equation number 2 will be y equal to uy t in place of t we can put x divided by ux minus half g x by ux whole square. And here the uy by ux is equal to tan theta. So we can present y equal to tan theta multiplied with x minus half g by ux square dot x square. And this is the equation which represents the relation of y, which is a vertical displacement, with the horizontal displacement x. And this is a trajectory equation of this projectile. The another form of this equation which can be written by putting the value of ux is u square cos square theta dot x square. So the equation of trajectory of a projectile is y is equal to x tan theta minus half g by ux square multiplied by x square, or this is another form of the same trajectory of projectile in form of initial velocity and angle theta. This equation is of the form of y is equal to ax plus bx square, and this equation represents a parabola. So the projectile path is parabolic path. Here, the important thing to note that this equation is valid only when projectile is launched and landed on a horizontal surface and the air resistance is 0. So basically the projectile motion is only under the influence of gravity. So there is no horizontal acceleration or deceleration. In horizontal direction, the velocity is constant, and in vertical direction, always there is an acceleration in downward direction, and which is equal to gravitational acceleration g. The equation of projectile trajectory can be used to find location of projectile on its path, or range of the projectile, angle of projection, initial velocity or maximum height, height of the projectile for any horizontal displacement, etc. Now let's do a couple of trajectory problems to build up our concepts. Problem 1. A projectile motion trajectory is given by equation, and we have to find out the angle of projection, the initial velocity, and the range of the projectile. So here we have the projectile motion equation. So we will need to just compare this equation with the standard projectile trajectory equation. So on comparing these two equations, we know that tan theta equal to 1 and 1 by 2 g u square cos square theta is equal to 1 by 20. From this equation, the first one, we know theta is equal to tan inverse 1, which is equal to 45 degree. So this answers to part A, where projection angle theta is equal to 45 degree. Now for finding the initial velocity of projection, we'll use this relation. Here the initial velocity u is equal to, if we cancel out this is 10, so this will be 10 g divided by cos theta. So here if we take a value of g as a 10, this u will be equal to 10 divided by cos theta, cos 45. Cos 45 is 1 by root 2. So this will be multiplied by root 2. So u will be equal to 10 root 2 meter per second. So the initial velocity of the projection is, which is answer to B part. So u equal to 10 root 2 meter per second. So now the last part of the problem is the range of the projectile. Now considering this projectile on a horizontal plane, we can say the point of projection, the y coordinate in the starting point is 0, and at the time of landing on the same horizontal ground, the final y is also 0. So the displacement is 0. If we put this value in equation of the projectile, we will get the two values of x corresponding to y 0. So here x minus 1 by 20 x square, this will be 1 minus 1 by 20 x equal to 0. So there are two values of x here, x equal to 0, which is a starting point here, and another x value is equal to 20 meter. This is, if I take x1, this is x2. So x2 minus x1 is equal to 20 meter. So here range of the projectile is equal to 20 meter. So in this way, if we have equation of projectile trajectory, we can find out different parameters related to its motion. Now let's move to the problem number 2. You throw a ball towards a wall with a speed of 60 meter per second at angle 37 above the horizon. The wall is 144 meter away from the release point of the wall. Now we have to find out at what height does the ball hit the wall? B. When it hits, has it passed the highest point? The C. What are the horizontal and vertical components of its velocity at the moment when it hit the wall? And the last one, if there were no wall, how far it would have landed on horizontal ground? So here the given information is u equal to 60 meter per second. The angle of projection theta is 37 degree and horizontal distance covered up to wall is 144 meter. The value of tangent of this theta is like tan 37 is equal to 3 by 4. Cos 37 is equal to 4 by 5 and sin 37 is equal to 3 by 5. Now to find out the height of a point at which the ball hits the wall, we can use the equation of trajectory of projectile. The equation of projectile is given by y tan theta dot x minus half g upon u square cos square theta x square. So by putting value of these, we can get the value of y, which is equal to tan theta here tan 37, which is 3 by 4. So 3 by 4, x here is 144 meter till wall. So 144 minus half, and value of g we are taking as a 10 meter per second square. So it's a 10 divided by u is 60. So u square is 60 into 60. And cos square theta, here cos theta or cos 37 is 4 by 5. So it means cos square theta is 16 divided by 25. X square is 144 into 144. Now we can simplify it. Here 4 it's 36 time, and here if we deduct 16 9s are 144. Again here 5 times, this is 12 times, and if 144 is 12 times, and this is 5 times, this is 2 times, and this is 1 time. It will remain 5 and here 9. So this will be equal to 108 minus 45, which is equal to 63. So answer to part A is 63 meters from the ground. Now we have to find out if the ball has passed the highest point during its projection before hitting the wall. So for that, we have to find out the two different instances when the ball is at the same height during its projectile motion. So from part A, we know the height of the ball is 63 meter from the ground when it hits the wall. And now this height of the ball will be at the two instants of the time during projectile motion. So if we say y is equal to 63 here, we will get x1 and this is x2, and this will be time t1 and this will be time t2. These two time instances tells us if ball has reached to the highest point before hitting the wall. To find out these time, we have to use the displacement motion equation. Y is equal to uy t minus half gt square. Right? Here ui is the initial upward velocity, which is u sine theta. So here by putting the value, u is 60, sine 37 is 3 by 5 multiplied by t minus half g is 10 t square, and y is 63 meters. So this will give us a quadratic equation, or for this quadratic equation we will have two roots of time t. So here if we rearrange this equation, it will be 5t square minus 36t plus 63 equal to 0. The roots of these equations are equal to minus b, which is 36, plus minus b square means 36 whole square, minus 4ac, 4a is 5, c is 63, divided by 2a means 2 into 5, and this will be equal to 36 plus minus 6 divided by 10. So here the value of t1, the time t1 is, we can find out 36 minus 6 divided by 10, which is 3 seconds, and t2 will be equal to 36 plus 6, which is 42, 4.2 seconds. So the ball will be at the same height, which is 63 meters from the horizontal, at time t1, which is 3 seconds, and time t2 4.2 seconds. So now we have to find out at what time the ball hit the wall. If ball hits at time t1 3 seconds, then definitely the ball is before it reaches to its highest point. To check this, we have to find out the horizontal distance or displacement traveled by the ball during the same time period. So ball horizontal velocity ux is equal to u cos theta, which is 60 cos 37, and this is 60 cos 37 is 4 by 5, and this is equal to 48 meter per second. Distance traveled is x1 equal to 48 into 3, which is 144 meter. And this is same as the distance of wall from the point of projection. It means the ball has hit the wall at time t is equal to 3 seconds itself, and that is before reaching to the highest point. So answer to part B is that the ball has not reached to the highest point before hitting the wall. Now let's move to the section C. So now we have to find out the horizontal and vertical component of its velocity. T here 3 seconds. So we have these two information from previous two questions where y is equal to 63 and t is equal to 3 seconds. Now we have to find out what are the horizontal and vertical components of its velocity. So basically at that instant of time, what is velocity in x direction and what is velocity in y direction. In x direction, the projectile doesn't have any acceleration, so velocity is constant. So Vx is equal to ux, which is nothing but 60 cos 37, and this is equal to 60 into 4 by 5 and is equal to 48 meter per second. Now we have to find out the velocity in vertical direction Vy. In vertical direction we have acceleration, which is equal to z, and here we are taking 10 meter per second square, which is downward direction. Using the equation of motion for constant acceleration, Vy is equal to uy minus gt. T is 3 seconds, so we can calculate uy here, 60 sine 37, and this is equal to 60 into 3 by 5, so this is equal to 36 meter per second. So here this is 36 minus 10 into 3, so this is equal to 6 meter per second, and this is positive. It means still this projectile was going up. The horizontal component is Vx, which is equal to, we already calculated, 48 meter per second, and the vertical component is 6 meter per second in upward direction. Now let's move to the last section of the questions. If there were no wall, how far it would have landed on horizontal ground? Here the projectile motion is along the horizontal ground. So we can use the equation of projectile trajectory for horizontal surface. To find out the range, we have to find out the displacement between starting point and the landing point. So in that case, y, the vertical displacement is 0. So here the equation become 0 equal to x tan theta, we know it's a 3 by 4, minus half, g value is 10, x square divided by ux square, which is 48 square. Here we can take x as a common. So this will be 3 by 4 minus half multiplied 10 divided by 48 into 48 x, okay, equal to 0. So the two values of x we will get from this equation. The first value is x equal to 0, which is a starting point of the projectile. The second value will come from this. So here if we solve this, this will become 3 divided by 4 into 2 into 48 into 48 divided by 10. This will be equal to 345.6 meter. So range of the projectile R will be equal to 345.6 meter if there is no wall on the way. So this way the equation of trajectory help us to find out the different parameters related to projectile. And now it is a time for question for you. Put your answers in comment box. I hope you would have enjoyed for today's session. If you think you have learned something new today, then please click like button and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.